All right, so in the past, we've dealt with area, which is a two-dimensional shape, right? So when we get into volume, volume is, think of it as finding the area of a three-dimensional shape. That's what we call volume. There's filling a space as opposed to a two-dimensional area, finding a surface area. So we're going to use this applet that we have and kind of discover some of these formulas. So the first thing we're going to do is the formula for a prism, which is a three-dimensional square, okay, is volume equals the base times the height. And the base is the area of a square, right? All right, so it's the area is the area of the base. So the base of a prism is a what? What shape is this? Cube, which is a square, right? The bottom piece is a square. So if the base is the area of the base, well, the base is the area of a square. What's the area of a square? Length times width, right? So you could also write this formula as length times width times height instead of base times height. Because you got to take the area of the base, and then when you multiply the height, that puts the three-dimensional part into it. Because now you're not just going area, you're going up. So now you're filling the space. So now what we're going to do is we're going to figure out, using this applet here, how many pyramids make up a prism. So I'm going to open this up here. All right. So here's the pyramid. All right. So I'm going to fill this up here. All right. And I'm going to dump it into the prism and fill that. So it goes to there. So what I want you to do right now on this line is take a guess. How many pyramids can make up a prism? We just put one in there. Write it on the line. Don't raise your hand. Write on the line. How many do you think? Make sure it's in pencil in case you need to erase. We just filled up one. Everyone got their answer down?
Yeah.
All right, so if I fill up a second one, there's two. And three. How many people said three? Good. So that means it takes three pyramids to make one prism, which means, we'll go back. So if it takes three pyramids to make one prism, right? Okay. So how one pyramid would equal how much of a prism then? If it takes three to make the whole, how much is one pyramid then worth? If it takes three of these to equal one of these, how about one of those? 1/3. So your formula for the pyramid is 1/3, and that's going to be its base, okay, which is, so you can write it like this, you can write it like this, or if we write the second formula, you can also write it as 1/3 length times the width times the height, or have it length times width times the height over 3. All these are the same formula. It's your area of the base, which the base of this is a square, times the height. Again, it's only 1/3 because it takes three of those to make a whole. Okay? All right, now we're going to compare a cone and a cylinder. Just move this a little higher so you can see. So we're going to do a cone and a cylinder on the applet. So here's the cone, and here's the cylinder. So take a guess right now how many you think it's going to take to fill that up. Write it down on your paper. Right where it says how many cones are required to fill a cylinder. Just go ahead and make your guess. We'll see if you're correct or not. Everyone got their guess down? All right, so let's fill it up. Okay, I'm going to empty it in the cylinder. How many people said 2? Almost. How many people said 3? 3 is your answer. So it takes 3 cones to fill up a cylinder. So, again, the formula for the volume of a cylinder is pi r squared times the height. Because pi r squared is your base. That's the area of the base, right? The area of a circle is pi r squared, right? So that's your base times the height. So again, but see in different shapes, bases mean different things, right? Okay, notice how this base and this base obviously are the same, but this base and this base are the same. But if I put base times the height to both of these are different shapes on the bottom, right? Square, circle. Okay? So pi r squared times the height is your formula for the cone or cylinder. So again, how many cones did it take to fill the cylinder? Right, so 3 cones equal 1 cylinder. So again, what's 1 cone in terms of the cylinder? 1/3. So again, you could have base times the height, which again looks very similar to up here, right? But it's not, because this base is a circle as opposed to a square. So again, you could have 1/3 pi r squared times the height, or pi r squared times the height over 3. It's understanding what the base is. Sometimes it's a little easier to stick with this one than this top one, because again, if you get used to saying just the base, they're different shapes which have different formulas, right? Area of a circle is much different than area of a square. Okay. All right, moving on. Now we got a square and a cylinder, or I should say a prism. So again, both of these had base times the height, right? So the formulas are alike because we're both saying base times the height, right? This is just what we got done talking about. Here and here. But our bases are different because the base of a prism is a square, and the base of a cylinder is a what? Circle. Can't spell circle apparently. Okay. So when you actually take what the base is, this is really this, and this is really this. So even though the formulas can be alike, they're really not, because their bases aren't the same. So they're the same in terms of saying base times the height, but they're different because their bases are different shapes. Circle, square. All right, last but not least, we're going to get into the other 3-dimensional shape that we're going to work on today. Is the sphere. 3-dimensional circle, a ball, right? So take a guess on how many cones you think it would take to fill one sphere. How many cones? Let me bring this up. How many of the cones are going to take one of these? Go ahead and make a guess on that line down the very bottom. Take a guess. All right, going to fill this up and dump it. How many people said 2? That's what it took, is 2 of them. 2 cones filled the sphere. Now again, we're going to discover this formula here. So we've come up with a cylinder, prism, and cone. So now we're going to do the sphere. So if I go to the back here, so this is on the back page, just continues. Okay, again, the volume of a cone is its base, right? This is the base, circle. And it took 1/3 of those cones, right, to fill that cylinder from before. That's why it came up to 1/3 times its height. Well, here they give you a formula. It says consider that the height of a sphere is actually 2 times the radius, right? What's the radius again? From the center to the edge, so they're saying 2r. So the height is the circle. I'm sorry. 2 times the radius would be, this whole thing would be 2r. Okay? So it says you can replace the height in the formula with 2r. So if I rewrite this, well, first of all, if I multiply the 2 through, what's 2 multiplied into 1/3? Remember, when I multiply a whole number into a fraction, where does the whole number go into? Huh? Well, we are multiplying into the fraction. What part of the fraction does it go into? When you multiply this 2, do we multiply by 3? What do we multiply by? The 1, so it goes in the numerator. All right, so this is saying like 2/3 pi r squared times the height. Well, I just said we can replace that h with what? So this is like saying 2/3 times pi times r squared times 2r. Well, if I take this 2 and multiply it into 2/3, 2 times 2/3 is what? Multiply the 2 into the numerator. 4/3. Okay, so I just multiplied the 2 into 2/3, and then I got an r squared times an r. Well, remember, when I multiplied r times r, what do we get? R squared, right? Well, when I have r squared and multiply it by an r, what happens there? Anyone have an idea? Huh? If I took an r and multiplied by an r, we got r squared. So if I start with 2 r's, r squared, and multiply by another r, we get r to the 3rd power, cubed, right? And this is your volume for a sphere. Volume equals 4/3 pi r cubed. Thank you. All right. So we've just spent part of this discovering all these little formulas. So now we're going to learn how to use them. Okay? So right below it says we're going to read this story on page 31. So I'm going to read this story out loud to page 31. Because now we're going to apply all the stuff we've learned. So it says this. It says Rocky Middle School is sponsoring a charity event. They plan to make and sell candles at the outdoor market in the city. Andy's committee is in charge of designing the candles. They designed 3 different shapes of candles. So they designed a sphere. Okay, there's that. They designed a cone. Again, I'm not the world's greatest artist here, so. And they designed a cylinder. Okay. The molds for the 3 types of candles have the same radius and height. So radius from center to cross, they're all the same. Because remember, the bases here are circles, right? And they're the same height. So they're not, one's not taller than the other. So basically it means they're the same candles, radius and height, but different shapes. So this says here, the price of each candle is based on the cost of wax plus markup for profit. If the cylindrical candle sells for $12, that's this guy right here, right? So if this guy sells for $12, what should the prices of the other 2 candles be? Well, how many cones did it take to make the cylinder, to fill it? 3, right? So the cone was what kind of size was the cone in comparison to the cylinder? 1/3 of the size, right? So if the cost of that cylinder is $12, and this is and the cone is 1/3 the size of that, what do you think the price then would be?
$4.
How'd you come up with that?
Times 12 times 1/3.
Yeah, he took 12 and multiplied it by 1/3. Because it's 1/3 the size, it's got to be 1/3 the cost, right? So 12 times 1/3 is $4. Now what about the sphere? What information can we use to find the sphere? How many cones did it take to fill the sphere? 2. So how much bigger is the sphere than the cone? It's double the size, right? So if the cone is $4, what should the sphere candle be? $8. Also, if it's double the size of this, right, and this is only 1/3 of that, the sphere is actually 2/3 the size of the cylinder. Could have found it out that way too. But you could also use the information you got from the cone in the sphere. So D, we're actually going to apply the formula because we don't do E. You can just X out E. So now we're going to actually find the volume. So if Andy decides to sell cylindrical candles with a radius of 3 inches and a height of 1.25 feet, how much wax does he need to make the candle? Well, that's a volume question, right? And we know the volume of a cylinder is what? Because that's what they're asking us for. Cylinder. What's the volume of a cylinder that you learned on the first side of the page? Volume equals what? 1/3. What is it? Pi r squared times the height, right? And we know that our radius is what? What does it tell us our radius is? In the problem here, what does it tell us our radius is? 3 inches. And what about our height? How tall is this thing? 1.25 feet. Well, we got a bit of a problem here, don't we? What's wrong with this problem right now? There's something wrong with this problem right now. Yeah, for us to use a generic measurement, we got 2 different measurements here, right? So let's think about how can I convert 1.25 feet into inches? Well, how many inches are in a foot? 12, right? So if 12 inches are in 1 foot, that leaves us 0.25 of a foot left, right? Well, 0.25 we know is to be what? A quarter, 1/4, right? So what's 1/4 of 12 inches? 3 inches, right? If I took 12 and divided it evenly into fourths, 3, 3, 3, and 3. So really, 1.25 inches, or feet I should say, is 15 inches. So now, for my height, if I put in 15, we can put our answer in inches, right? So use your formula. 1/3 pi, and then r is 3, right? I knew that didn't look right. There's no 1/3 in a cylinder. It's just pi r squared. So pi times 3 squared times 15. Now I'm going to open up the calculator here to show you how we can easily type this in. The calculator can make this your life a whole lot easier. So you know that 3 squared is what? 3 times 3. 9 times 15 times. Now just put pi in. So pi, remember, is the little blue guy here above the arrow. So if I hit second function, because it's a blue button, and hit that, it puts pi in for me. So instead of putting 3.14 or 3.1415, you can just do this, and it calculates it out for me. So we'll say 0.1, 424.1. So this is going to equal 424.1. And now what unit of measurement besides inches do we have to put on here? We're talking about volume. 3-dimensional. Cubed. Because area squared, so this is cubic inches. So a candle that's 15 inches tall by 3 inches wide, cylinder, is going to need that much cubic inches to fill it. Now the one thing you can't do is think of 424.1 as a long measurement length. Okay, because it's not. It's how much is going to fill an area. All right. For example, if I had this Kleenex box, one Kleenex could be a certain distance, but it takes a lot more of them to fill the inside of it, right? So a volume is always going to have a bigger number than what you're used to seeing in like area, because you're talking about filling a large space as opposed to a surface area. Okay, so that's a big difference. All right. So there's your introduction to volume. So your homework tonight is going to be this. Okay. And you got lots of time. Let me pause this video here.